Hello, everyone. I'll be your TA for today. Can somebody tell me how many people do we expect for the class? In that case, let's wait for a couple more minutes before we start with the class. Okay, let's start. Any group wants to go first? Anyone? In that case, let's start with group 3.
Yeah, we are group 3, and one of our teammates is not online yet. We are still waiting for him.
Okay.
And we today we present the challenge 4 because last week our code have some problems, so the professor told us to present this week.
Okay. Do we still need to wait for your partner for that?
Yeah, maybe we will message him to ask him. Yeah.
Okay. Then let's move on to group 2. Group 2? Is there anybody from Group 2 present?
I think that in group 2 there's only one leader and there's no group mates. In the evaluator pitch file, I just saw that.
Oh yeah, he dropped the course, so there's no group 2 anymore.
So which groups are there? There's 3 groups, but I don't know which
1,
numbers.
3, and 4.
Okay, then Group 4?
1 and 4 presented last week.
Then it's only Group 2 presenting today?
I think only one group.
So Group 3. Oh. Then we wait for Group 3 to have all its members, and then we start with the presentation.
And they didn't respond to us, so our teammates online will start. Okay, and recording. Okay. Okay, and can you guys see our slides?
Yes.
Okay.
Yes, we can.
Okay, we are Group 3 of Challenge 4. And today we are going to talk about understanding word embedding, BERT, SR, and ITL. And I'm Wu Zongrui. I'm responsible for dataset pre-processing part of this project. We use IMDb movie review dataset, which contains a total of 50,000 labeled reviews. 25,000 were used for training, and the other 25,000 for testing. The test here is binary.
May I ask one question? Did you do the separation for the training and the testing?
What?
Did you manually do the separation for the training set and the data and the testing set?
Testing set, and we use code to separate them. Yeah.
Oh, but why did you do a 50-50 split?
50-50, and let me think how to explain.
Typically we do a 75-25 split or 80-20 split, because you still need to have a larger amount of training data set than a testing data set.
Yeah. The way why I use this method is that we found a website talk about it, so I just covered their ideas. Yeah.
Mm-hmm. Did it explain why it does that then?
Sorry for. Hey, the 50-50 is my idea from the website, but I keep it to give a more strict condition to know whether our model is strong or is robust for overfitting issues. So we give it a more strict condition.
Okay, carry on.
Okay. Our task here is binary sentiment classification. We are predicting whether each review is positive or negative. Now, the challenge for us is not just to load the data, but to make sure it's fully clean, tokenized, and ready for BERT, all while staying under a 10,000 neuron constraint. The first step was cleaning the raw text. We removed HTML tags, special characters, and digits. Everything was converted to lower case to make the input consistent. We then mapped the sentiment labels positive to 1 and negative to 0. These cleaned and labeled reviews were stored in a new column called clean review, which we use for all the following steps. These steps ensure that the model will not be distracted by unnecessary formatting or inconsistent case. Okay. And this page, the other teammate will talk about it.
Okay, so sorry for the title. The title should be the model construction and architecture. So I use BERT for sequence classification for from the transformer module. And the loss is a built-in binary cross-entropy loss just from the BERT for sequence classification. Okay.
This is the flow diagram shows the full process. We start with a raw text, clean it, encode the label, tokenize using BERT, then pad or truncate to a maximum length of 512. In the end, we output the input IDs, attention mask, and the labels, all of which are necessary for BERT fine-tuning. This pipeline ensures that the input is clean, uniform, and semantically meaningful. After tokenization, we wrap the data using a custom IMDb dataset class. This class stores the input IDs, attention mask, and the labels as PyTorch tensors. Then we use PyTorch's data loader to handle batching, shuffling, and loading the data efficiently. We also split the dataset into training and validation sets using an 80-20 ratio. This setup makes the input fully compatible and with the training procedures, and super easy to plug directly into our model pipeline.
Okay, so
Yep.
The 80-20 split is from the training set?
80-20. Yeah.
Because before you split it into 50 and 50 for training set and test set.
Oh,
you
sorry.
reduce-
Sorry, I didn't correct that. Yeah.
Oh, so it's still 50-50.
Yeah.
Or is it 80-20?
50-50. I typed the raw number. Sorry.
Okay.
Right. And this is our sample output batch from our data loader. You can see that each input has a shape of 512 tokens, along with a matching attention mask and the corresponding label. the batch is ready to be used in BERT fine-tuning. All of this pre-processing ensures that the data flows smoothly into the model without breaking structure or format. And that's the part of mine. And other teammates will talk about model and optimizer setup.
Who is this teammate?
Let me see.
Is the one that hasn't
member
arrived?
in the mid. Only 3 of our teammates is online, and the other 2, we call them in line group, but they didn't respond.
So the person who should be presenting this part is not present.
你们联络都得到他吗？
And
OK
可以
OK OK OK，
他在现场，他在现场。
Oh, he's online. Okay.
Next step is wait a minute. First we first we set the model and optimize setup. Instantly a classification model. Next, which the model load the pre-training BERT with a classification head. Use the AdamW optimization with a learning rate of 2e. How to read this? Set bash site 16 and create a data load instance for training and testing. Then the next step is training and evaluation function. Switching to training mode, load over branch, compute loss, accumulate prediction and true label, then return a average loss and accuracy. Next, switch the evaluation mode, disable gradients computation, similar compute loss and accuracy. Yes. And then the when train load, we run for 3 approach. Then record and print per approach loss and accuracy. Then store the approach wise metric for plotting later. Okay. Next. Then the last step is embedding visualization and custom analysis. Extract intermediate embedding or pre-logic vector for BERT, redux to 2D where PCA and TSNE and plot schedule diagram to observe positive and negative review distribution, apply k-means clustering, and compute the score to assess clustering quality. Okay. Yes.
Who's presenting the results?
And let me ask in like group. Oh, this part is those two missing guys. Yeah.
In that case, you can just improvise this part. It's just the results anyways.
So skip this part.
No, you can just improvise it. Just tell me what you see here.
Oh, okay. I'll try my best. You can see our loose over epochs is our test loose, and when it over 1.0, it rise, and before it might be stable, and the trend loose is consistently falling, and you can see a dot that at 1.0 it dropped from different rate. Yeah, and accuracy over epochs is that our test ACC is not growing so sharp, and our trend ACC is much larger. And when it turned to epoch turn 1.0, it slow down its increasing.
So it's starting to overfit.
What same page?
Yeah, so after the first epoch, so after 0.0, the train has a higher accuracy than the test, meaning that it's starting to overfit after the first epoch. So the test and the train should be having the same performance. But as you see, as the epochs increases, they're starting to separate. So there's a
Yeah.
gap, meaning that your model is overfitting the results of the training and not generalizing well.
Um,
But it still has a good performance in terms of
okay, let
accuracy.
me add on some of my thoughts. So we can find that the loss over epochs as at the second epoch, we could find the test loss slightly increases, but very small. But for the accuracy over epochs, we find the accuracy didn't drop. And the accuracy between training and testing is around 5 to 6%. But at the setting of the 50-50 split in my design, this can be referred as a suitable or even good condition. So our model can perform better if the split is more easier, not a strict 50-50.
Mm-hmm.
So here is the comparison to the CNN we finished at the last presentation. So basically, we can find the CNN overfitting more so the difference between test accuracy and training accuracy in both pre-test, post-test, or center train center test is is around 10% drop or even 12-13%. So the overfitting is more strict here. So we can infer that the BERT can be more robust toward overfitting than the CNN.
Mm-hmm. Wait, so what exactly are you doing with the CNN here?
Sorry?
Can you explain again what you're doing with the CNN in this slide?
The CNN does the same mission
Mm-hmm.
of INDB classification just like the BERT, but we we do so is to know which one can does better, which one is more unlikely to run into overfitting state. And
Mm-hmm.
the CNN is also work under the 50-50 build, and it got a worse result. So we found that BERT is more suitable for this kind of task.
But then in the fourth epoch 4.0, it with the purple and the green line have a very high accuracy and they're very close together. Oh wait. No, never mind. It's post test.
The dash line
Oh yeah,
is
yeah.
for testing.
Okay. Okay, I see it now. Yes, you're right. BERT has a smaller gap of separation than the CNN. Okay.
And 我问一下，这个是什么？这个是 K-means 吗？
ECA.
Okay, so this is the visualization of PCA of BERT embeddings. So we can know that the separation is quite good, quite
Mhm.
suitable for this kind of classification. Most of the dots, each dot represent one data, one review. And the zero or the blue dots represent the negative reviews, while the orange ones represent the positive ones. 下一张。This one is the visualization of TSNE. So we can infer that it does even more better than the last one, because we see there are fewer dots in the opposite area. We can
Yes.
find fewer orange in the blues or blues in the oranges. So we found that TSNE method is more suitable. But each method are okay for using, but the TSNE does even better. Okay, this is our work distribution. So I'm in charge of birth and loss function and some parts of today's representation and our Wuzhong Rui does the data summary and math. And maybe some pre-processing skills.
Good job.
Thanks.
So that was challenge 4.
Yeah.
Anybody has made any progress with challenge 5? No one? Sue, do you have anything to present?
No。第五个 challenge，有人有进度要报告的吗？
Is challenge 5 PDF on Slack group yet?
I
哦，
think
就
that
是
there's
上一
no
次发错的那
other
个。
challenge for that.
It's the one we sent by mistake. Challenge 5. Oh, I guess I can send it again. 我再发一次好了。OK， 好。
Well, in that case, if there's nothing else to present, I guess we can just dismiss the class.
So challenge 5 is going to presentation is on next week, right?
Yes.
Okay.
Any other questions? Well, if there's no more questions, then the class is dismissed. You may leave. Ciao.